Welcome to the deep dive. For centuries, we pictured space as this static 3D stage.
Right, just an arena.
Exactly. And time, a
Yeah.
completely separate thing, like a universal clock just ticking away for everyone, everywhere. Rigid containers, right?
That was definitely the standard Newtonian view. Solid, predictable.
But then came Einstein, and he turned that whole picture on its head, revealed something pretty revolutionary.
Absolutely. He showed they're not separate at all.
They're actually one single dynamic thing called spacetime.
A unified fabric.
So our mission today for this deep dive is to unpack what that really means. How this idea completely redefines, everything from gravity to how you experience now.
It's a fundamental shift.
Yeah, get ready for a shortcut to getting your head around one of the most fascinating and frankly mind-bending topics in physics.
Okay, so at its heart, space-time. It's basically a four-dimensional framework, a continuum.
4 dimensions, so the usual 3.
Right, your length, width, height, the space part, but woven inseparably with time as the fourth dimension.
So not just space plus time, but one thing.
Exactly. Think of it like this. Every single node, everything that happens has a unique address, not just where it happens in space, but precisely when it happens in time.
Okay.
Every object you included exists within this unified cosmic weave, simultaneously in space and time.
Okay, I think I follow that, but it's still hard to picture space and time as a single fabric. Like, how does this fabric actually behave? What does it do? Is it just there?
That's where it gets really interesting and where Einstein's theory of gravity, general relativity comes in. It gives us a way to visualize how it behaves.
That's so.
Well, the common analogy, and it is just an analogy, remember, it's simplifying 4D into 2D, is like a big flexible rubber sheet.
Okay, the rubber sheet. I've heard of that.
So imagine you put something really massive on it, like our sun. It creates this big dip, right? The curvature in the sheet.
It sinks down.
Now, here's the key insight. If a smaller object, like Earth, rolls nearby, it doesn't get pulled towards the sun by some invisible force like Newton thought.
No. So what happens?
It just follows the curve. It follows the bent path in the geometry of space-time created by the sun's mass.
So gravity isn't a force pulling things together.
Not in Einstein's view, no. Gravity is the geometry. It's the shape of space-time itself telling objects how to move. It's a completely different way of looking at the stage the universe plays out on.
Wow. Okay, the Earth is just following a curve, not being pulled. That is...
Yeah.
Yeah, that's a massive shift. So where do we actually see this happening? What's the proof out there in the cosmos?
Oh, this model explains so much that we observe. Take gravitational lensing, for example.
Lensing, like a lens.
Exactly. Light, even though it has no mass, still has to follow the curves in space-time. So when light from a really distant galaxy passes by a massive galaxy cluster on its way to us.
The cluster's gravity bends space-time.
Precisely. And the light follows that bend. So from our perspective, the distant galaxy looks distorted, magnified, sometimes even like multiple images. We see this all the time with powerful telescopes.
That's incredible. Light bending around whole galaxies. Okay, but does this warping affect anything else? Like, does it mess with time itself?
It absolutely does. That leads to another key piece of evidence. Gravitational time dilation.
Time dilation, meaning time changes.
Yes. Time actually runs measurably slower in stronger gravitational fields. It ticks by more slowly closer to a massive object.
Wait, really? Slower?
Yes.
Yeah.
And this isn't just some abstract theory. Your GPS relies on it every single day.
GPS. Huh.
The atomic clocks on the GPS satellites orbiting Earth are in a slightly weaker gravitational field than we are down here on the surface.
Okay, so time runs a tiny bit faster for them.
Exactly. It's a minuscule difference.
Yeah.
But if the GPS system didn't constantly correct for this relativistic effect, the timing signals would drift. And those tiny drifts would add up fast, making your navigation completely inaccurate. Your map app would send you blocks away.
That's amazing. It's built into the technology we use constantly. Okay, what about the really dramatic stuff? Have we ever, seen space-time itself ripple?
We have. And that's perhaps the most profound confirmation. In 2015, scientists directly detected gravitational waves.
Waves in space-time.
Actual ripples traveling through the fabric of space-time itself. These were caused by incredibly violent cosmic events, like two black holes spiraling into each other and merging billions of light years away.
Wow.
Detecting those waves was huge. It confirmed a prediction Einstein made 100 years earlier. And crucially, it showed that changes in gravity, these ripples travel at the speed of light.
Ah, so gravity isn't instantaneous like Newton thought.
Definitely not. It takes time for the news of a gravitational change to travel across space-time carried by these waves. It solidified Einstein's view over Newton's instantly acting force.
Okay, this changes, well, everything about how we see the universe operating. So
Yeah.
bringing it back down to Earth a bit, what does this all mean for us, for you listening?
Well, the big takeaway is that space-time isn't just a passive stage like an empty room where things happen. It's an active, dynamic player in the cosmos.
It actually does things.
Right? It curves, it stretches, it ripples, it flows, all based on how mass and energy are distributed within it. It's this incredibly elegant, flexible picture that replaces the old, rigid view. And modern science just keeps finding more evidence that confirms it with amazing accuracy.
So for you listening, thinking about space-time isn't just some abstract physics exercise. It's about realizing that the space around you and the time you experience are fundamentally tangled together.
Deeply interwoven.
They shape every single moment, every movement you make. Maybe consider this. Being here now isn't just a fixed point in a static grid. It's actually your unique path, your trajectory through this constantly flexing four-dimensional cosmic dance. How does that change your perception of this very moment?